of antimatter.
Sounds like something straight out of Star Trek, right?
Kinda, yeah. But it's a real thing, and it's way weirder than fiction. We're going on a deep dive into this mysterious stuff today.
Buckle up. It's going to be a wild ride.
We've got some awesome notes here from the future of antimatter research at CERN. We're going to break down exactly what antimatter is, how CERN is on the cutting edge of researching it.
And why it matters for understanding, like, the entire universe.
No big deal.
Yeah, no big deal.
So first things first, what is antimatter? I mean, I know it's not just something they made up for sci-fi.
Definitely not. Think of it like this. You know how everything around us is made of matter? Well, antimatter is like matter's evil twin, or like its mirror image, but flipped.
Flipped how?
The particles are the same, but their charges are opposite. Like you have an electron, which has a negative charge.
Right.
Antimatter has a positron, same particle, but positive charge. Protons and antiprotons, same deal.
So it's like a photographic negative, but for like the fundamental building blocks of everything.
Exactly. And here's the crazy part. When matter and antimatter meet,
They annihilate each other.
poof, gone. Converted into pure energy.
Like a huge explosion.
Huge E is an understatement, is the most efficient energy conversion we know of. Think Star Trek's warp drive, but like, for real.
Okay, that's insane. But then, if the Big Bang created equal amounts of matter and antimatter, why didn't everything just cancel out? Why are we even here?
The million-dollar question. It's called the baryon asymmetry problem, and it's one of the biggest mysteries in cosmology. Why is there more matter than antimatter in the universe?
Yeah.
Did the antimatter, like, get lost somehow?
I mean, I'm glad it did or we wouldn't be here, but that's a pretty huge cosmic riddle.
It really is, and that's where CERN comes in.
Right, the Large Hadron Collider, the LHC.
Yep. It's not just about smashing protons together, although that's pretty cool too.
Yeah, those proton collisions get all the headlines.
But the LHC also helps make antimatter particles, like antiprotons.
And they use those antiprotons to actually create and study antimatter atoms, right?
You got it. And CERN is home to some seriously groundbreaking experiments in this area. You were reading about the LHC experiment, right?
Yeah, they actually managed to trap antihydrogen atoms.
It's insane. Antimatter is notoriously difficult to handle because, well, it annihilates on contact with, like, everything.
Makes sense. So how do they even trap it?
Magnetic fields. Very, very strong ones. The LFEK team created this special magnetic bottle that can hold on to antihydrogen atoms long enough for them to study its properties, like measure its spectrum and compare it to regular hydrogen.
To see if there are any, like, tiny differences that might explain this whole matter-antimatter imbalance thing.
Exactly.
That's incredible. And then there's the GBAR experiment, which is even more mind-blowing. They're trying to figure out if antimatter falls up.
Yeah. It sounds crazy, but it's a totally valid question. We know how gravity affects matter, but with antimatter, we're not entirely sure it's possible it interacts with gravity differently.
So, like, imagine dropping an antimatter apple, and instead of falling down, it shoots up into the sky.
That's the idea. The GBAR experiment is using lasers and other super precise techniques to measure the gravitational interaction of antihydrogen. If it does fall up, it would completely revolutionize our understanding of gravity.
All right, so we've got these awesome experiments that are trying to answer some fundamental questions about the nature of antimatter.
Yeah.
But how does all this research actually, affect us?
Well, aside from potentially rewriting physics textbooks, antimatter research has some pretty amazing potential applications, especially in medicine, specifically cancer treatment.
Right, I read about that. It's like super precise radiation therapy.
Yeah. See, when matter and antimatter annihilate, they release a ton of energy, and this energy can be harnessed to destroy cancer cells.
So you could target tumors with like antimatter beams,
Right.
and because the energy release is so localized, it wouldn't damage the surrounding healthy tissue as much as conventional radiation.
Exactly. It's still in the early stages of research, but the potential is huge GE.
And beyond medicine, there's the whole energy production angle, right?
Right.
I mean, if we could figure out how to safely create and control antimatter.
We'd have the most powerful energy source imaginable.
Right. But that's a big if. It's super difficult to create and store antimatter because, well, it annihilates with anything it touches.
Exactly. But who knows what the future holds? We're constantly developing new technologies. Maybe one day antimatter power plants won't be just science fiction.
So, to sum up, antimatter is this mind-blowing stuff that's helping us answer some of the biggest questions about the universe. Why is there more matter than antimatter? What are the fundamental properties of antimatter? How does it interact with gravity?
And it's not just theoretical. It has the potential to revolutionize medicine and maybe even change the way we power our world.
And on top of all that, there's a potential connection between antimatter and dark matter, which is another huge GE mystery.
Oh, yeah. Dark matter is this invisible stuff that makes up a big chunk of the universe, but we can't directly observe it.
All right, another deep dive for another day. But how are these two seemingly unrelated things connected?
Some theories suggest that dark matter might interact with itself through a new type of force, and this interaction could produce antimatter. So by studying antimatter, we might gain insights into the nature of dark matter.
Wow. So we've gone from what is antimatter to potentially unlocking the secrets of dark matter. It's mind-blowing to think about all the possibilities that antimatter research holds.
Absolutely, and it underscores something really important. We've only scratched the surface of what we know about the universe. There's so much more to discover, so many mysteries to unravel.
And that's what makes it so exciting.
Exactly. And one last thought-provoking question to leave you with. If we ever do manage to create and control antimatter on a large scale,
What kind of ethical considerations would we need to address?
precisely, we're talking about the most powerful substance known to humankind. How do we ensure it's used for good and not for, well?
World-ending explosions.
Let's hope it doesn't come to that. But it's definitely something to think about as we venture further into the realm of antimatter.
It's a reminder that scientific progress always comes with responsibility.
Well said.
All right, folks, that's our deep dive into antimatter. If you want to learn more, definitely check out the CERN website. They've got tons of information on all the latest research. And who knows, maybe one day we'll be talking about antimatter power plants like they're everyday things.
I'm ready for that future.
Me too. Until then, keep looking up and keep asking questions. The universe is full of amazing things waiting to be discovered.
Absolutely, and some of them might just blow your mind. Literally.
Okay, on that note, we'll see you next time.
See ya.
Bye.